support in IT, I believe. Oh, there we are.
The movie can go now. I'll refer to it a bit later once we show it. So the microphone is on, right?
Yeah.
No, it's not amplified, it's for the recording.
So no, the microphone is not amplified. So speak loudly. And when there are questions, speak microphone to the audience.
Alright, thank you. My name is Arnold Loonstra. Before I start, let me express my gratitude to Peter because he's organizing the IoT Dev Room year in, year out. And I really like this room. Like this room here. I don't know if you know, but Peter is also one of the main characters behind ZeroMQ. Today I will talk a bit about ZeroMQ. I don't know, people know ZeroMQ? Yes? Oh, I really like ZeroMQ and also the work Peter is doing because, in my opinion, it makes stuff simple again. And if we need anything nowadays, it's simple stuff that still can empower us. So, I also work with the Z25 Foundation, and they have the mission to empower artists and inspire developers. I hope I can give a bit of an inspiration today. This research was also done in affiliation with Leiden University. So, I'm going to switch off the... Put it to black now and then, when you're only looking at the screen. So my talk today will be about the continuation of ZOCP. ZOCP was a talk I gave last year. Did anybody attend the talk last year? I'll introduce it a little bit in a while. I'll first introduce a bit context, then I'll show a little demonstration and a code example. Then I will talk about the user test we did, and conclude, and then we can have questions. So, but first let me create a bit of context. I'm not only talking about the Internet of Things. This is the Internet of Things room, but I'm mostly interested in making technology easier to build stuff with. So, and I've been triggered by the IoT developments because it's a real use case for stuff communicating with each other. So my research started there, getting stuff connected, but then my research involves what I like to call creative coding. And creative coding is just programming, like probably most of you also do, but with the aim of being expressive rather than being functional. So it involves a lot of people who are using the computer just to do stuff, to get stuff done. And it nowadays ranges from art to rapid prototyping to people just tinkering with technology. And what I also noticed is that most of the creative coders, they learn to program autodidactically. So they don't have a computer science background. So that also implies a bit that they have less thorough knowledge of the computer. I consider myself a creative coder as well, and I expect a lot of you are creative coders as well, or should ambition to be one. But I also think that the Internet of Things hype also needs to cater for this audience, because there will be an increasing demand for people to be able to control all their devices. And I refuse to create a GUI in which you can push buttons and do things, or create a black box which a company can solve itself. So I'm really focused that you have to program. You have to learn to program. But the question is, what kind of program? So last year I presented the ZOCP project, which provides a very simple approach to connecting devices. And they connect to the network, and you can orchestrate them using an editor. And I'll quickly show it. So in here, this is what we call the node editor. I will also refer to it later as the actor editor. And I have some terminals from which I can just start some programs. So these are very, very basic examples. So this is just a program which has some variables. And it's all instantly found by the node editor, or actor editor. And this is another program. And as you can see, they are connected now. So and I can add more programs, like a Qt slider mode. So you can connect it like this, and now if I move, right, you see it? You get the idea. If you want more details about this, look in the FOSDEM archive, because I explained it all out. So, I also showed when you were walking in, there was a movie playing. That's a lab session we did, and we just play with artists and developers and test all this technology and try to be creative with it. But we've run on multiple occasions into a certain problem, and that's this problem. And as you perhaps, or most of you probably know, this is caused by processors not becoming faster anymore. So instead, we have to deal with processors containing multiple processors. And that's not only in your desktop computer, even your mobile, your embedded device, they contain multiple cores nowadays as well. Because it's more power efficient, for example. But we need to program them. And this has happened, this still start. You run into this, you have this really fast computer and then you program stuff and then only one processor is used and you wonder why. Especially if you're not a computer scientist. So yeah, we have to program threads, for example, or concurrent programming. And a lot of scientists seem to agree that it's very complicated. Some even say that it's too complicated for humans. So who knows about programming threads? Okay, and who thinks it's really easy? Anyway, just to be sure, I conducted a survey in creative coding communities with exactly this question. So, the blue colors represent sequential, normal programming, and the red colors represent concurrent programming. And you see a score from 1 to 5, 1 being very easy, 5 being very difficult. Well, it's quite clear that it's experienced as being very difficult. So, what to do now? Well, if it's really that difficult, we might need to abstract away from this, because this is what we do with computer anyway. We don't deal with all the voltages inside a computer. So perhaps there's a new abstraction needed. And Stein is a scientist who argues for a new paradigm. In this model of this is sequential programming what we use to. And it's just step by step, and the result is the program. But she argues for a computation as interactions paradigm, in which entities communicate with each other, and the result of the program is the result of the interactions amongst all these entities. And we can talk a lot more about new paradigms. I don't want to go there. But what I found really interesting about this is exactly what we are doing with ZOCP, but then on the network with all the devices connected. So I was thinking, hey, let's do do this inside the computer. So, yeah, can people still follow me? I sometimes get feedback this is too fundamental. So, what I did, I have adopted the ZOCP model for inter-thread communication. And I've developed a framework based on these paradigms. So, and here you can see, this is a code example I showed last year as well. And this is a new framework which is based on popular creative coding frameworks like Open Frameworks or Processing. Do people know this? Open Frameworks? Processing? Processing might be best known because it's very similar to the Arduino IDE. So, yeah, this was just the old-fashioned way. People had a lot of trouble with the run methods because it was blocking. And you have to create this event loop and understand what it's doing. So in the creative coding frameworks, you usually have an update method, which is called every 60 seconds or whatever how fast you want it to be. So this is how it's done. So, and this is still just sequential programming. It's important to understand. So, well, it's nice to create this framework, of course, but yeah, I did this with in Leiden University, and then as a scientist you have to measure. So I created 3 tests and invited a group of creative coders to see how they would find this, how they would experience this programming paradigm. So I'll show some tests, some of those tests. Fit on the screen. So, this is not very functional, huh? But this is what typically being done in creative coding. Yeah. It's only 800 by 600 the screen, so it's messy quite quick. So, this is just a program running 4 threads which have to draw on the canvas. And if you know about graphics, this is usually a trouble because only one thread can access the graphic card. So in here you can see what the program is doing under the hood. So, you see 4 threads. It's quite a simple program. And you have one thing. So this was the first step. And yeah, people had to just got this assignment and then had to create this program. So the second test was the dining philosophers problem. Anybody familiar with that? So 5 philosophers sit around the table, they all have a bowl of rice, and they have a chopstick beside the bowl. Well, when they eat, they acquire food for thought, and well, they philosophize about their thoughts, and only 2 philosophers can eat at a time because they have to get 2 chopsticks. So this is a program you have to design there. It's a bit of an abstract problem, especially for creative coders, but let's see how it looks. So, there's no visual output, but one of the solutions is to do a waiter then you have Kant here, Socrates, Aristotle, Plato, and Descartes. So, and in the way there is waiting on the tables, or monsters. Well, you get the idea, right? So, and the third test I had to do, I cannot show it because I need specific libraries to do this, and I don't have this on this laptop. But it was you have to process images of a webcam. So I'm going to skip this one. So we did all these tests in a single day, so it wasn't strange that people, or the subjects, they didn't finish all the tests, but it wasn't required either. We just wanted to know how difficult they would find it, or what trouble they would run into, and we ran into 3 challenges during the test. First of all, they had to understand the framework. And, yeah, it's new, so, then they had to wrap their head around the assignments, and then they had to design a program. So we interviewed the candidate of the subjects, but we did not find any reason to believe the subjects were having difficulty with concurrency. So that was really nice. And when asked to rate difficulty of programming, again, the blue colors represent sequential programming, the red concurrent, and then the green is with the framework. So it was easier than concurrent programming. So, to conclude this framework is available. We already found that the framework was very suitable for interconnected systems, which is very relevant for the Internet of Things. But now we found that it's also very applicable to safely enter concurrent programming. So what we also noticed is that the subjects who were already familiar with ZOCP through the network had less difficulty designing a programming for multiple processes. And it's then important to understand that this framework, it doesn't prevent concurrent issues. It only, the user is only less prone to make these mistakes as long as they follow this model of entities communicating with each other. It's a message passing. And on top of that, the user, it really helps users to create concurrent programs, but it still provides access to threads or all the old-fashioned or other approaches into programming. So if you really need more performance of specific solutions or specific libraries, you can. So it's very sustainable framework. So what's next? I like to call this code orchestration. That's out of Compass School as well. But the protocol, ZOCP, and then this framework I will call SPOF. I really need a new name, or am I out of my need? Anyway, we need to port to C. We did this in Python. But another important aspect is we need synchronization primitives, and which will probably be your next research to implement synchronization. Time's up. I hope you can see the link between Internet of Things or interconnected systems and modern programming. Otherwise, ask me to discuss it. I left out technical details and stuff, but feel free to ask me. And yeah, I would like to thank some people, especially Aldo Hoeben. He did a lot of work on the note editor. He made the notes in Qt. But also, I'd like to thank the MATLAB in the Netherlands and Z25, of course, and ZeroMQ for being a great library and community. And I have to thank my girlfriend, because I could borrow her laptop, because I only have shitty laptops nowadays. So, I'll be happy to answer any questions.
We have 2 minutes for questions.
Well, quick one then. Questions? Oh.
Yes, I have a question.
Yeah?
Yeah. So what kind of synchronization primitives do you use right now, or not any?
Not any at all. Except, well, it's not entirely true because 0MQ provides some patterns which you can use for synchronization. And of course message passing itself is a certain synchronization. But for example, if you put the webcam, I didn't show the webcam test, but there you had a webcam image which was being processed by multiple threads and then had to be drawn on the screen again. And you could see the lag. That the thumbnails or the edited images, they were behind the main image. And this is where synchronization is needed.
So I remember a discussion with a BOS developer that was telling me that BOS was one of the first operating systems that had a standard C library that was including multiple core, the fact that you can use multiple core transparently from the developer side, just including the standard library, and you could use the cores without taking care of multi-threading. So I was wondering if there is a similar library for Linux that you don't have to take care too much about.
Well, it's a good question because you don't need libraries and programming stuff to utilize multiple processes of your computer. Because if you run an operating system and you run multiple programs, it's already being divided to all the processors. So this is the easiest method of utilizing multiple processors. And also this is very well supported by this framework because like this is the paradigm you can work with. And the first one is just multiple programs which can communicate with each other. And by that, you use all the CPUs of your computer. The other one is just the threads are the same. The only difference is you can hand over data, which is way faster because you can pass a pointer.